Ever wonder why your AI assistant might stumble over a sentence in Maltese or Swahili? It turns out, the same tools that power smart assistants and translation apps aren't equally effective for all languages, especially those with limited digital presence. Today, we're diving into a groundbreaking study that's rewriting the rules of AI language tech. Let's break down why smaller models can sometimes outshine the giants, and what this means for the future of inclusive AI. Here's the thing. Large language models, or LLMs, are like superpowered robots trained on oceans of text. They can write essays, code, even crack jokes. But here's the catch. They're mostly trained on data from high-resource languages like English or Chinese. Imagine trying to learn math using only textbooks in one language. Your understanding of other languages would be limited. That's exactly the problem for languages like Maltese, which has fewer than 1 million speakers and way less online text. This study took a deep dive into Maltese, an official EU language that's last in global language tech accessibility. Researchers created a new benchmark, a set of 11 tasks ranging from text classification to story generation, and tested 55 models, from tiny ones to the behemoths like IA 101 and MT0XXL. The goal? To see if bigger is always better, or if smaller, smarter models might have the edge. Here's what they found. Smaller models often outperform the big ones, especially in creative tasks like writing. Why? The team discovered that exposure to Maltese during training was a game changer. If an AI had seen Maltese text early on, it performed way better. It's like teaching a child to read by first exposing them to books in their native language. Suddenly, the whole system clicks. Instruction tuning, where models learn to follow specific commands, also helped, but there was a trade-off. The more complex the task, the more resources it demanded. But here's the twist. Fine-tuning smaller models for specific jobs, like translating legal documents or analyzing sentiment, gave better results than tweaking huge LLMs. It's like training a specialized chef versus asking a generalist to cook a complex dish. The big model might know more, but the smaller one can focus on the recipe. The study also highlights a bigger issue. Most AI research is biased toward high-resource languages. By showing that traditional, smaller models can sometimes beat the big guys, the researchers are pushing for a shift. They're not saying LLMs are bad, just that for languages like Maltese, a different approach might be better. So what's next? This isn't just about Maltese. It's a call to action for developers to think beyond, bigger is better. Maybe the next breakthrough in language tech isn't about scaling up, it's about scaling smartly. Thanks for watching. If you're curious about how this applies to other languages or want to explore the benchmark yourself, check the links in the description. Stay curious and we'll see you next time. Think of AI language models like a student learning a new language. A dictionary, the dataset, gives them vocabulary, but without a conversation partner, the model, they can't really use the language. That's where projects like Multi-ULX and Taxi 1500 come in. These aren't just lists of words, they're carefully crafted datasets designed to teach AI how to classify legal documents, sort text, or even detect cultural context in 1,500 languages. It's like giving AI a roadmap to navigate the world's linguistic diversity. But here's the challenge. Most AI models are trained mostly on English data. So researchers had to get creative. They tested models like MT5 and IA by asking them to do tasks in languages like Maltese or Swahili, languages with far less digital footprints. To make this work, they didn't just throw raw data at the models. They designed special prompts in those languages, sometimes translating English instructions with tools like Google Translate, and then refining them with native speakers. It's like teaching a student to solve a math problem in a language they're still learning. Every step has to be carefully guided. The results? Some models surprised everyone. For example, IA 101, a model trained specifically on Maltese, outperformed bigger models when tackling tasks in that language. Meanwhile, larger models like BLOOM struggled, unless they'd been exposed to the language during training. It's a key insight: size isn't everything. A model can know 100 languages, but if it's never practiced a specific one, it'll still stumble. Here's what this means for the future of AI. By focusing on low-resource languages and building models that can transfer knowledge across languages, researchers are making AI more accessible to billions of people. Imagine a farmer in rural Kenya using an AI tool to analyze crop data in their native language, or a doctor in Peru diagnosing patients with a multilingual assistant. The potential is vast, and this study is just the beginning.